Distance. So the first thing about distance is the segment addition postulate. It states that if 3 points A, B, and C are collinear, which means they're on the same line, and B is between A and C, then AB plus BC equals AC. So there's a couple things about that. First of all, this is the picture of what that would look like. So we have points A, B, and C, they're on a line, and B is between. Now notation, when you write AB, that is referring to the length between points A and B. So you notice there's uppercase, it says the first and last point, there's no other notation, this is referring to a length. It's if we add A and B, so the length of A and B, to the length of B and C, then we get the length from A to C. So if you add the two pieces, you get the length of the whole thing. You can also have more points, so maybe it's the length of 3 pieces equals the whole thing, but either way, the pieces add up to the whole thing. So we're going to use that. So we have if AB equals 9 and BC equals 12, then AC equals. So when you're doing this, I highly suggest, if you're not sure, draw a picture for each of them. So if A to B equals 9 and B to C equals 12, then A to C is adding the two pieces together to get the whole thing, and 9 plus 12 is 21. Then if we have this next one where it says if AC equals 25, so this starts with the whole thing. If the whole thing is 25 long, it might be meters, centimeters, units, who knows, and AB equals 3, then what does BC equal? So if you have the whole thing and you have a piece, that becomes a subtraction problem. So we're going to go 25 minus 3, and that means that the length from B to C is 22. So now, not all of our problems are going to just be numbers. Some of them are going to have variables. So for instance, we have the collinear points of E, F, and G. We have the length of segment EF is 8x minus 14, and the length of segment FG is 4x plus 3. Now I'm going to model something you're going to see on your assignment. The first thing it's actually going to ask you is to use variables to write the segment addition postulate, and this would be that EF plus FG is going to equal EG. So if you add the two pieces together, it's going to equal the entire whole piece. So if I take that formula and substitute what I know, I can get my equation. So EF is 8x minus 14, FG is 4x plus 3, so that's the adding my two pieces, and it equals the whole thing, which is 49. So if I combine like terms, I get 12x minus 11 equals 49. If I then add 11 to both sides, I get 12x equals 60, and if I divide both sides by 12, I get x equals 5. Now for this particular problem, I wasn't just asked for x. I was also asked to find EF and FG. So I'm going to use x equals 5 to answer my questions. So if from E to F is 8x minus 14 and x equals 5, then EF is going to be 8 times 5 minus 14. 8 times 5 is 40, and 40 minus 14 gets us 26. And then FG, you have a couple of options. You can either just do 49 minus 26, because you already know the whole thing is 49, and piece is 26 to get 23, or you can plug x in and go 4 times 5, which is 20, plus 3 is 23. Let's try another one. So we have the line segment HI to J. So we have HI. This is the segment addition postulate with our points substituted in, plus IJ, so that's the first piece plus the second piece, has to equal the whole thing, HJ. So let's plug in what we know. We know that HI is x plus 3, because that's what it stated on the picture. We know that IJ is 2x minus 19. And we know the entire thing right here has a length of 23. So if we combine like terms, we get 3x minus 16 equals 23. Then if we add 16 to both sides, we get 39. So 3x equals 39. And if we divide both sides by 3, we get x equals 13. Now again, that's not our final answer, but we are going to be able to use it to find our final answer. So hi is x plus 3, so I'm going to go 13 plus 3, and that has a length of 16. ij, again, I can either plug in 2 times 13 minus 19, or I can just do 23 minus 16, and 23 minus 16 is 7. So those are the lengths of my two segments. Then we have one that's broken up into 3 pieces. So first of all, the segment addition postulate would tell us that the length from AB added to the length from B to C, added to the length from C to D, has got to equal the entire thing A to D. So our goal is going to be to find the length of BC and AD, because those are the two that we don't actually know. We don't know that middle section, and we don't know the full thing. So if I substitute in what I know, from A to B is 10, I actually know that one. B to C is 2x plus 4, and C to D is 3, I know that one, and the entire thing is 3x plus 5. So to solve this, I'm first going to combine like terms. So I have 2x plus 17, 10 plus 4 plus 3, equals 3x plus 5. Then I'm going to subtract 2x from both sides. I'm going to have an x plus 5 on the right side and a 17 on the left. And I'm going to subtract 5 from both sides to get x equals 12. Now, if I use that to plug in my information, if I want to find the length from B to C, x equals 12, I'm going to do 2 times 12, which is 24, plus 4, which is 28. If I want to find A to D, I can either plug in the 12 and go 3 times 12 plus 5, or I can add up all my pieces. 3 times 12 is 36, plus 5 is 41, or 28 plus 10 plus 3 is 41. Now, one more segment addition that we can use is actually the segment overlap theorem. So the idea is there's going to be some overlap between them. So if A, B, C, and D are collinear and in that particular order, then AB equals, if AB equals CD, then AC equals BD. Conversely, if you flip those two around, if AC equals BD, then AB equals CD. Okay, what the heck does that mean? So what that's saying is, I can state that the length from A to B, if I can state that the length from A to B and the length from C to D are the exact same length. So let's just give it a number right now to give us a concrete answer. Let's just say those both have a length of 3. I'm going to use my graph paper, okay? That middle segment from B to C has a length right now on my graph paper of 2. So that's the A to B equals C to D. Let's just say they're both 3. If I include that middle segment in both of them, I'm going to get the same answer. So if I go A to C, which is 3 plus 2, I'm going to get the same answer as if I go from B to D, which is just 2 plus 3. So if you know those n pieces are the same, you can add the middle to either of them and it's the same thing. So the converse is saying that if you add those two pieces together and they're the same, then the endpoints are the same. Because basically if you take off the middle, you have the same thing on each end. So let's see if we can do this. I highly suggest that you draw yourself a picture for these ones. It's going to help a lot. So I'm going to use my picture right here and delete all of my lovely stuff. So again, this is your paper. So like if you want to draw one in like pen and then lightly write over it in pencil as you go for it. So if A to B is 17 and AC is congruent to BD. So we need to talk about this. This is notation. If you have A line like that, where there are no arrows on each side, that is calling it a segment. That is referring to the line itself. It's not referring to the length. Because remember, up here, if we just say the two letters, this is referring to a length. How many meters or kilometers or units long is it? But if you have that bar on the top, it's referring to the segment. So the way you would say this is if segment AC, now this is the word for congruent. It's like an equal sign with a squiggly on top. Congruent means that they are the same. They have the same length to them. They're the same shape. So if segment AC is congruent, is the same as segment BD, then the length, now again, look, there's no bar over the top, so this is now referring to a length. Then the length of CD is what? So let's take apart what this is saying. So it's saying if from A to C is the same as B to D. So if you take out this middle and don't worry about that part that they both share, then AB is 17, then CD should be 17 also. So that is just saying that if they share a piece in the middle, then the two sides should be the exact same length. Now let's do a problem with variables. So this one says if AC, so if from A to C is 3x plus 1, and from B to D is 2x plus 5. Now, at that moment, we don't know what's congruent yet. So before you go anywhere, make sure you keep reading. So just then, it's just the statements of what they are. Now, here's the important part. And segment AB is congruent to segment CD. So if AB is congruent to segment CD, I now know, because of the segment overlap theorem, that AC and BD have to be the same because they are the same segments on the edge, just added with that one in the middle, that overlap that they both share in the middle. So I can say that 3x plus 1 equals 2x plus 5. And if I solve that, I'm going to subtract 2x from both sides. I'm going to subtract 1 at the same time, and I'm going to get x equals 4. So that's the first part of my answer. What is x? It equals 4. Now the second question it's asking, oh, this should be a B, is what is the length from B to D? So if I plug in x equals 4 into BD, I'm going to have 2 times 4 plus 5. So that's 8 plus 5, which is 13. So that has a length of 13.